Reliability analysis methods of multi-area fault diagnosis and location in power grid with missing information. Abstract, aiming at the problem of poor position accuracy of traditional power grid fault diagnosis methods. This paper studies multi-area fault diagnosis and positioning reliability analysis of power grid under lack of information. By analyzing the topology of the distribution network, the location of the fault points in the distribution network is quickly determined, and the fault treatment scheme is given. Based on the lack of information, the simplified structure and mathematical model of key equipment are introduced. The matrix is used to describe the switch state and the topological relationship, and the fault diagnosis module based on information loss is designed by using the grid fault diagnosis algorithm based on matrix operation. It realizes the faster detection of multi-area fault diagnosis and location, improves the reliability of the detection results, and provides convenience for fast fault location and processing. Keywords: lack of information, power grid failure, fault diagnosis, fault location. First, introduction. With the rapid development of power system, more and more distributed generation access to the distribution system, so the structure of distribution network is more and more complex. When the distribution network fails, accurately and efficiently finding out the fault point or area is the prerequisite for rapid resolution and power supply recovery as soon as possible, which is of great significance to improve the reliability of the distribution system. In the power grid fault diagnosis, the lack of information technology is used to establish the relevant spatial topology and mathematical correlation model, which can make the fault diagnosis quickly and accurately locate the specific switch gear. At present, the common fault location of power grid is mainly based on dispatching operating model. This model lacks necessary line simulation, does not provide line load transfer scheming, and the control of the line is completely based on the influence of natural on or off. Because the switch control is status and the line relationship are not quantified, the problem solving lacks the relevant mathematical model support. The algorithm is inefficient when the structure of the line changes, and there is no information about the hierarchical structure of the overhead line. To multi-area fault diagnosis and location reliability of power grid. 2.1 Multi-area fault location algorithm in power grid. Power grid fault start algorithm is used to detect the time of fault occurrence and is a prerequisite for fault analysis, diagnosis, and processing. The whole power grid fault diagnosis system in the application of the actual power grid is unattended real-time operation. The core of the fault start algorithm is the start question. When the timetic data of the system meets the start question, the start signal is sent to the fault diagnosis system. An ideal starting question is that it can start quickly and reliability in case of system failure and has high starting sensitivity in normal operation state of power grid, including overload, frequency fluctuation, and system oscillation. It will not start reliably. In the digital protection drivers, according to the different protection principles, the classical electric quantity startup critical are divided into steady quantity startup critical and sudden variable startup critical. And the steady quantity startup critical are mainly divided into excessive startup critical and insufficient startup critical. The starting criterion of sudden variables is based on the calculation and the comparison of the changes between the measured values before and after the fault. Generally, it has high sensitivity than the starting criterion of steady-state variables. Therefore, the sudden variables are widely used as the starting conditions in the fault diagnosis system. 2.2 Fault diagnosis system. Fault diagnosis of distribution network. There are many algorithms about the fault type discrimination and the fault process section, but most of them inevitably use sequence component to diagnose fault type more accurately. For example, according to whether there is a zero sequence component, it can distinguish whether it is grounded short circuit or undergrounded short circuit. According to whether there is a negative sequence component in the measured current, it is necessary to distinguish between two-path short circuit fault and the three-path fault. It can be seen that the sequence component obtained by systemical component method has obvious advantages and importance in power grid fault analysis and diagnosis. Corresponding to the single-path short circuit grounded fault, it has the characteristics of positive sequence current, negative sequence current, and zero sequence current, which can be represented by the composite sequence network diagram of positive sequence, negative sequence, and zero sequence series. Similarly, for other types of faults, different boundary conditions in the form of sequence components will also be obtained. The main characteristics of distribution network missing information fault categories can be summarized as follows. When the distribution automation terminal at the key position is missed or misreported, the fault location method of traditional single information source will often lead to misjudgment. For example, when the distribution terminal in the fault section fails to report all the adjacent downstream distribution terminal misalign, it will get the wrong conclusion whether using matrix algorithm or artificial intelligence algorithm. This is an inherent defect of fault section location by using fault over current information alone, and the multi-source information fuzzing can serve this problem well. It is assumed that there is a fault on section 11, but FTU on section 2. First, to upload the flow information to the control center of the main station due to communication reasons. That is, the fault over current information field is 10010100010000000, and the load point information field code by CS is 00000010. In this case, the fault section state and its basic probability distribution obtained by BPSO algorithm are shown in the table. Third, analysis of experimental results. In order to improve the reliability of this method, the experimental verification analysis is carried out, taking the undergrounded system of 20 kV power grid in a certain area as the experimental environment. The experiment is built in MATLAB environment, in which the hardware environment is Intel Core 3-5501G memory, and the operating system is Windows 8. Suppose that a large number of network communication nodes are distributed at 2000 in the optical fiber environment. 2000 uniform array area written according to the requirements of C++ can add multiple functions of Microsoft, including the system running through the whole Windows program, user interface, and field operation. The experimental parameters are shown in the table. According to the experimental environment and the parameter setting results, the experimental content is analyzed. Take the first line and the sixth line, I point E point. Line 1 and line 6 as an example. Input line 1 and line 6 into address input, i.e. 10001 and x6001. Click the three-phase current button to collect the three-phase current and the zero sequence current of the line, as shown in the table. Fourth, concluding remarks. More and more distributed generation connected to distribution system has become the development trend of power grid in the future. But the existence of distributed generation will affect the size and the direction of fault current, so the traditional fault diagnosis method of distribution network is no longer applicable. The fault diagnosis method of distribution network based on fault power direction creation and information missing makes full use of both upload and measure fault information to ensure the accuracy and the efficiency of fault diagnosis of distribution system with distributed generation, and improve the speed of fault diagnosis in the complex situation of information loss or distortion. This method can still accurately determine the fault area of distribution network, which meets the needs of modern distribution network fault diagnosis.